I'm Cassie. I'm coming to you from New York, and I'm going to talk to you about whose job AI automates and where you fit in this space. Because I understand a lot of you are graduates from the sciences, from computer science. Many of you are pursuing masters, PhDs. I was there in your shoes. What you will see in the slides here is that this is not an academic type talk with a bunch of equations. This is more level setting for you of what this space looks like and where you fit in. So let's dive in, shall we? The first major spoiler, and actually, let me just double check. We are hearing me, yes? Yes? Awesome. Okay, I see thumbs up. I hear nothing is great. Okay, so today's AI revolution, as the spoiler slide already showed you, is not an AI revolution at all. It is instead a design revolution, a user experience design revolution. And to understand what's happening in this space, what you need to realize is that, and I know that academics hate this the most, I feel you, but language drifts, and humans, being the strange creatures that we are, we use language imprecisely, unfortunately. And so the way that the term AI is used has really drifted. Now, it hasn't drifted within the communities that use it. It's more like a set of nesting dolls where the original community got kind of wrapped by another community that was using the term a different way. And now we have another one entirely. And what they were is, first, you've got the classic AI researcher. So that's algorithms research. And imagine that from all the way from 1956, when the term was born, all the way through to, let's say, the first decade of this millennium. When you heard AI, it was typically from someone who was excited about it because they were into algorithms research. That was like the epicenter of what was going on. Of course, there was also sci-fi, but we're not going to bother with them because we know that the sci-fi thing is a lie. That has never been what serious people thought AI was about. That was more like a marketing ploy. When the thing is not having business impact, how do we get grant proposals, right? You know this game. So we've got AI researchers who are that inner nesting doll. But it's all theory, because what do you need in order to get AI going? You need massive amounts of hardware. You need massive amounts of data. That was not available for many of the early decades, right, of AI. Then, about 10-ish years ago, what you have is this blossoming of a new community that is all talking about AI, and that is the AI builders. So I, like many of you, came out of academia, where what I was interested in was the research side of things, and specifically the algorithms research side of things. And I was a research statistician, so can it be nerdier than that? But then I started seeing all that potential that was suddenly possible with the blossoming of hardware and data. But look, when you're going to solve practical problems with AI, that doesn't mean that you're going to be solving them easily. So the big players and the people really talking about AI 10 years ago tended to be those large enterprises who could afford all the effort that goes around the big teams and big data sets that it takes to really succeed. So when you heard the hype then, and when you attended conferences, if you picked a randomly selected conference, sometimes you'd still hit the researchers, but mostly what you were looking at now was builders, and two kinds of builders: the engineers who build with code, and the investors who build with their wallets. little joke there. I don't know if I got titters because I can't hear you, but it's also unfortunately quite true. A lot of the advertising and hype back then was really about investors. Now, today, there is a third group that is surrounding both of these, and that is the users. What happened in November with ChatGPT is not about a fundamental breakthrough in algorithms, nor is it a fundamental breakthrough in large-scale systems and what they're capable of. What it was user experience design. Now consider this. If you went back 10 years you were probably interacting with AI systems when you went online. Google's products were running them. If you got recommendations from Netflix, you would be interacting with an AI system. Shopping online, all of it was AI. And again, how are we using the term AI here? A lot of it was logistic regression, let's be real. But today, they tend to be used kind of interchangeably in industry. I gave up long ago, especially because you've got these different groups using the words in different ways. So a joke that I like is if it's written in Python, it's probably machine learning. And if it's written in PowerPoint, it's probably AI. So that's kind of how industry has been going about things here. And so these systems, whether or not they were based on neural networks, they were based on neural networks quite early at Google, they tended to be quietly given to users. So if you think about user experience design, what the philosophy was, set AI aside for a moment. Let's say you have some experience with a website. It is really bad UX design if you have to know whether you're dealing with HTML or JavaScript or what. Most users don't need to know that. They just get a great experience online. That was the fundamental design philosophy. It was like that on purpose. Seamlessness was what everybody was aiming for. And so if you were going to interact with an AI system, you also shouldn't know about that. That would be breaking the magic. It just has to work. It has to serve you these predictions at scale, and not to you at scale. You're one of many users receiving one at a time, but we are serving a large population at scale. That was the idea, and they don't need to know about it. It's all seamless. So look at how different post-November AI is. That is because for the first time, people who are not experts, who don't know anything about the space, are given AI as a raw material, AI for its own sake. Now that is such a new and powerful and different paradigm. That's what's happening. Let me just check my mic again and see if you can all hear me. I'm beginning to suspect it might be rustling. Oh, there we are. Okay. Let's put that where we can get it. Okay. So that's the big change. It is that all of a sudden, users are invited to play with AI for personal productivity as a raw material to whatever they're going to do next. And here's the magic of, basic numbers. There are fewer algorithms researchers than there were engineers building, and fewer again than there are users interested. So most of the discussion today is really about users who are like, wow, I get to do something I couldn't do before on the internet. So this is about user experience design. To remind you, the first paper on transformers, that T in ChatGPT, that came out in 2017. And this was available. You could go on GitHub and you could play with LLMs. But why wasn't everyone talking about it? Because it wasn't productionized for users. But I'm getting ahead of myself. So this is me. I've been at Google for nearly 10 years, served as chief decision scientist for almost 5. And I call myself a recovering statistician. I guess you never recover. We're the grumpiest of the data science kind, originally out of academia as well. Very, very interested in what we can practically do with these technologies to make the world better. But this isn't about me. This is my colleague Paul, and this isn't about Paul either. This is Paul's wife's aunt, Dora. And the thing about Dora is that Dora is a computer. How do we know this? We see it on her marriage certificate from 1950, and it says very clearly that Dora is a computer. But you know what's even better? Dora's husband is listed here very clearly as an engineer. So this is one of those early days in history where a computer has managed to marry her engineer. Maybe there's more of this to come. So who automated Dora's job? That's the big question. And the answer is we are a tool-making species. That is how we have the nice things we have today. That's how I'm able to come to you from New York City, even though you are halfway around the world from me. That is because of the inventiveness of the human spirit. Whenever there is some way to do it better, we humans find that way. We invent something. So AI is a tool. The question is, what is it a tool for? Well, it is actually a tool for automating, not Dora, but the software engineer, if you will. So that's a marvelous comeuppance, right? It is the software engineers and the hardware engineers, the inventors, who all automated Dora's job. And now, guess whose job AI is coming for? Ha, this is actually a nuance here. It's not going to put anybody out of a job, but the job that AI is augmenting and expanding is the programmer's job. So let me show you this very briefly. You already know what computers are for. That's turning inputs into outputs. You get it. How does that happen? Via a recipe, fancy word for model. This audience, I'm sure, prefers the word model, but I really like to use the word recipe around businessy types, because when they hear model, they assume something much more glamorous than what's actually happening behind the scenes, including assumed correctness and assumed safety, which we don't want to do. When we use simpler words, like examples instead of data, recipe instead of model, we allow people who would otherwise be dazzled into not thinking about these systems in a safe way to kind of come back down to earth and see what we're talking about. So the difference between the traditional approach and the AI machine learning approach is about where that recipe comes from. Traditional programming, you do it with instructions. You write code step by step for the computer to follow. And we know that in order to automate a task, you need to know how to do it. That's the key thing. Because how are you going to come up with those instructions if you don't know how to do it? With AI, the difference is that you're going to use examples or data to get it done. So this is already a paradigm that we use with one another, always have. We teach by instruction or we teach by example. But for the longest time, we didn't have those examples and the hardware to be able to pull this off, even though we had many of the algorithms already. What are the algorithms for? For finding the patterns in the data. And when you've done that, what happens is then you can generate that recipe automatically, and you've got that. The computer is then able to send inputs through that recipe to get outputs. So far, so good. So then, what are we actually looking at here in this revolution? First, we have an unprecedented leap in automation, because as you allow people to express their wishes with data instead of instructions, what do you get? First, what you get is that you don't need to know how to do the task to automate it. And this is a double-edged sword, of course, because how will you know if the task is being done right? That's tricky. The other thing is that you should never go for an AI-based solution when you can approach it the traditional code way. And I'm not saying don't use data. That's what analytics is for. Go explore, go figure out if the data seem to be aligned with your perception of the world. And if you're going to one-up it and you're going to make the decision statistically, fantastic. You're going to set up your hypotheses and you're actually going to test whether you would want to craft your model by hand, essentially, the way that seems to be lining up with reality. That's the old school way of building models. You are really doing a lot by hand as an analyst or as a statistician. And throughout the process, you're kind of loading whatever you see into your human brain and massaging those models and results. There's a lot more automation with the AI thing, because what if the whole recipe is just too difficult to fit in your head? Well, you're not going to be able to come up with the instructions either. I mean, think about what makes a cat a cat. When you do one of those classic cat, not cat tasks. Coming up with what catness is really difficult. But if you had enough examples, maybe you could pull that recipe out and use it. That's what we're doing. And because that recipe is complicated, you're not going to be able to read it from top to bottom. Debugging it is really hard. When we talk about interpretability and explainability, anything that comes out of a system like that, that attempts to tell you how one of these systems works, is like boiling an entire book down into a tweet. It is not the real book anymore. A lot of the essence is lost. And maybe a lot of the important essence is lost. So the true explanation of how the model works just doesn't get in there. It's not that any particular line of a neural network is anything complicated, right? Like, it's a bunch of addition, multiplication, and then you send it through, some ReLU, which just means drop the negatives. That's not that difficult to wrap your head around any particular line. But now stack them all up and ask somebody, what on earth is it doing? It's hard to wrap your head around, just because it's long and boring mostly. And as you do any kind of compressing it down, you still end up with an incomplete understanding, just because of the mismatch between what fits in your head and what fits in a computer. And the data promise is really a promise of memory. If we go back to fundamentals, what we are doing here is we are playing with augmented memory. And we're able to do it at scale. A lot of the magic that looks like machines think is just us taking all of our incredible amounts of data that we have collected and putting that in a way that something with much wider, bigger memory than we have, that's something can use that for pattern finding. So it looks like magic, it really isn't. But to understand today's AI, I propose this analogy for you. Your data are like your ingredients, your algorithms like appliances, models to recipes, and predictions to dishes. This is something that is very, very useful if you take it to anybody who works in the AI adjacent space, but is not a technical professional. This helps set expectations properly. For example, when it comes to data, if your ingredients are bad, you can't expect success. Garbage in, garbage out. But really see that. You can't take someone else's ingredients, you know nothing about them. It's just some truck has shown up with a bunch of stuff, vegetables in the back, and you think you're going to turn this into chopped chip cookies? Not necessarily. The provenance, the quality, the processing of those ingredients, all of it matters. Similarly, what researchers tend to work on is building a blueprint for a new and better kind of microwave. It makes total sense why all the training programs really emphasize how does that microwave work? How does that algorithm work? If what you're working on is building that blueprint for a new and better one. But let's not get confused here. Building a blueprint for a new and better one is not the same thing as building a usable microwave that someone would want to use without wanting to cry. That's a different job. Like we all know when I've worked in a biomedical engineering lab, a hardware lab, and anything a grad student makes in there is held together by hope and sticky tape. Really, you slam the door and the thing falls apart. The best engineering lab label I've ever seen was a big sign in my old lab, and it just had one word on it, and it said, "Don't." So that's the kind of move from any kind of theory that we do to something practical. Where we get those user-friendly microwaves is from platform engineers. So these larger teams that are essentially selling a kitchen experience on. Then innovating in models, innovating in recipes is a very, very different job from innovating in algorithms. And that is something that was a major gotcha 10 years ago, because what companies would do is they would hire a bunch of algorithms researchers. And I know there are so many of you in here, right? PhD students who are interested in algorithms research. So you get hired because once you get your PhD, you're freshly minted and you're ready to go work. But what you're actually being asked to do is to be a chef, not a builder of a better appliance, and not what you're actually trained to do, which is an inventor of blueprints. Because when do you need to invent blueprints? When your current stuff is not good enough. Most of the time in industry, that is not the problem that your boss has. Your boss wants to typically innovate in the recipe. They want to make a gluten-free, sugar-free, vegan croissant that also tastes amazing. So how do you go about doing that? You don't know if you're going to get success. You have to dabble, you have to tinker, you have to play. That is the antithesis of how we want to go about when we're doing algorithms research. We want to prove out a bunch of things. We want to run things against benchmarks. Oh, by the way, algorithms researchers are not necessarily well suited for the job for another reason. And that is that when you are inventing better microwaves, appliances, whatever, you don't want to be testing them on that random truck of ingredients that has pulled up. You want your clean, purified water, an ingredient that is well known to you. You understand its performance in other settings so that when you make improvements, you can actually diagnose whether it was your improvements that are causing the results. So you want super, super simple testing data. for your algorithms, right? Benchmarking data. And that's not the same thing as all that thorny real world data. So that's another way that you get lost when you sort of pop into the real world of data science, where things are messy, where real humans made those ingredients. It could be a whole truck of rotten carrots, who knows? And then, of course, what you're serving is dishes to your customers. But the big difference now is that all of a sudden, instead of here's a cookie, eat it, don't eat it, your customers have a very different experience, which is take the thing, do whatever you want with it, turn it into a Valentine's Day basket, spray paint it gold, doesn't matter. So this is where the fascinating difference comes in. AI is suddenly both a tool and a raw material for other people to build with. And here's where a lot of the regulation problems come in. When you offer someone a digital raw material and they misuse it or they hurt themselves with it, whose fault was it? Should we not have supplied the raw material if you were going to do something silly with it? Or, is it on you to really know? Especially since in the AI space and in the practical AI space, there are big walls between every step in this process. So if you are a company like Google or Microsoft, OpenAI, you do work in the entire space. But if you are a smaller player, typically you are only supplying one piece and you know all about your piece. And by the way, when you talk to startup people and they're telling you they do AI, please insist, ask them which part of this are you actually working in? Because there is no way that you do all of it. It's too complicated, too big for a startup. So because you have these walls in between each of these functions, it's very difficult to think about trusting the system, right? Someone's just given you a bunch of chocolate chip cookies. Are they radioactive? You don't know. You don't know anything about the ingredients. You don't know anything about the models. You don't know what cooked them and how and were they fully cooked. So trust here is difficult. Is explainability the way to trust? I personally don't think that that is the case, at least with how explainability and interpretability are being done at the moment. But those areas are certainly really, really good areas of research for trying to back engineer and find ways to debug a system that you didn't build. So what kind of task does AI automate? This is a question that I hear a lot in industry because people are worried. The answer is that foundationally, the kind of task that we're automating is code writing. That is what we're doing. We are automating code writing with data. And I don't mean in that Copilot tools kind of way. I mean, we are using examples to generate recipes. We're using data to create models. The models play the same role as code. It's the same thing. And so it is the software engineers or the developers' job that's being augmented. Is it going away? Not at all. Now that we're unlocking the second half of automation, there is so much to do. There's a better world to build. So we're not stopping. It's not like developers aren't necessary. It's just that now you have this major new tool in your toolbox of how to automate, that you can automate without knowing how to do the task. So I like to call this automating the ineffable or automating beyond human expression. But then people are like, well, what about the fruits of AI? How is this going to affect the labor market? What kind of job does AI automate? And to this I say, look, let's look at Dora the computer. Nobody particularly mourns the loss of that job in the long run. In the short run, of course, change is hard and we need to manage that compassionately. But in the long run, what we're seeing is many of us are making use of Dora-like abilities in our other jobs. It is a task that has changed. Not necessarily, a whole class of job has of course gone away, but it's more like people who would have been doing Dora's job are now able to elevate and do more complicated things than a bunch of, essentially what she was doing was sums, addition, multiplication, etc. So what kind of task then, and not job, does AI automate? And for this, I need to invent a new word, and I present to you the word thunking. So we already know what thinking is. Thunking is that mindless, think of it as that dull sound of a brick, thunk, thunk, thunk. It's that mindless execution of what you've already decided to do, when you've solved the problem, when you have figured out what needs doing and why, when you've gone from being fully engaged in a conversation where you're actually reacting and bringing the best of yourself to it, to just sort of checking out and executing, or when you've thought about what you want art to say, and now you just have to get it done. Thunking is that part of the job that you can do distracted, listening to an audiobook perhaps. It's not the highest cognitive engagement piece. And so I think of this as the thinking bit is understanding why you need to get through that door and how, and the thunking is actually going up and pulling the handle, getting it done. AI does not automate the thinking piece. It doesn't, and it cannot. That's really important for us to realize. 2 reasons. 1, philosophical. It's very easy to make the argument, and much easier than the other one, that thinking is a fundamentally human and decision-oriented trait, especially depending how we define it, and that what we are able to do is simply automate the bits in between. So that's if you're going philosophical. The more practical reason that AI is not automating thinking is that what is captured in the data is what the AI system learns, and not the rare stuff, but the frequent stuff. The frequent and repeated stuff is not the spark of brilliance. It is the execution. That is what is in the data. So that is also what is being automated. And then people ask, can AI be creative? To which I remind you of this wonderful ready-made by Marcel Duchamp. So what happened here in 1917 was he went and he found a urinal. He signed a name on it, not even his own name. He brought it to the exhibition and he said, this is art. And I agree with him. This is art. Why? Because it is a statement in this long conversation that humanity has been having with itself. This visual conversation when it comes to visual art. And the object is the next sentence in this conversation. And so what we are looking at here is a human artist using an existing ready-made. And it's not the porcelain company who made that thing that should get the credit for the art. It is that spark of brilliance that allowed him to see that this is the next thing that needed to be said. I would never credit the porcelain company, and I would never credit an AI system. What you see behind the scenes in AI art is hundreds, if not thousands of duds of people curating, looking at what is the thing that says what I'm trying to say. But the great difference is that now we artists can be unlocked faster. And I think of myself sometimes as an artist, though I have an academic and engineering background, because that's the funnest piece. Not necessarily the execution, but that spark of brilliance, that spark of creativity. I believe that that is fundamentally human and is staying human. And so people will say, what if we let AI do the thinking? Again, I reject this notion. But where is the thinking then? Because there always is thinking. It's either in the users who are figuring out how to use output of these systems in a way that serves them. And so there you can think of AI as a tool for decision-making. But you should also think of AI as a product of decision-making. There is thinking behind all of these systems that kind of kicks it off. And to see this, you must understand that there are 2 statements, 2 subjective statements that are the 2 lines of code fundamental to the creation of any AI system, and the rest is execution and window dressing. Yes, it's a heroic task, and it's amazing that you work on it, but look at it from a really high-level point of view. When you do traditional programming, you agonize over every line, maybe 10,000 lines, maybe 100,000 lines of code. You think about whether each one is right or wrong, and if you make a mistake, we call that a bug, right? Humans do make mistakes. But some person has to agonize over all of it. If you pull in a package, you just install some package, someone else in your species still thought about every line. Whereas behind the scenes in machine learning and AI, really there are only 2 lines, and the rest is getting it to work, right? Fiddling with unwieldy PyTorch and TensorFlow and whatever it is, and just like forcing that thing to take your data. Because the only two lines behind here are optimize this goal on that data set, go. So much boiled in to two very subjective decisions. And that is what creates the whole AI system, the foundational AI system that then might be used as a raw material into additional AI systems. So some people sat in a room and thought, hopefully carefully, about which goal do we want to optimize on which data set. By the way, optimizing which goal is not the same as picking an objective function, right? If your business goal and your objective function are the same, if the statements are the same, I usually worry. Usually that tells me people didn't think very carefully about what they were actually trying to achieve in the world. So two lines that are given so little thought. And this is how we are amplifying impact of whoever on that team, whatever leader we hope, has decided what's the goal and what's the data set that are appropriate. We are scaling individuals up the way that into influence that only kings and popes could have had hundreds of years ago. So the blast radius of bad decision-making is increasing rapidly. If what everyone else is doing is all the engineering and huffing and puffing to execute on these two lines, well, who checked that those were two good lines? Do we have the research that we need in order to make sure that this decision process is well handled? And the answer to that is no. That's part of my own work, is to really re-inject decision scientific principles into that first part of AI. But right now, it's all fast and loose. And too many people in this community think that the algorithms or the data are the point. That has never been the point. The point is the why. The point is, how is it going to change the world? And when we're talking about that, we are talking about stepping up to a genie, like to a magic lamp, and making a wish on behalf of millions of people, of billions of people. Do we have the skills to do that? Where are the academic disciplines that are stepping up and talking about that? And researching not only how do we actually think about decision-making behind large-scale systems, but also how do we think about creating education programs so that the people doing this have some wisdom to guide them? Are we training up teams that are able to assist properly? This should be a PhD level position that is directly advising a decision maker, not making those decisions on their behalf, but able to talk about the consequences of design choices in fairly complicated statements on which goal and which data set. I want to see the research go here. And that is not where the research is going. The research is on hardware, the research is on algorithms, and a little bit on data. And even on data, this should blow your minds. Think about the major that teaches you how to create a data set for a large-scale system. What major is that? Is that statistics? Is that AI? Is that analytics? Is that data engineering? Is that social science? None of them address it directly. And yet we are building a world, a data-fueled world, on a foundation of what? Data that's designed by hope, by accident. That's chaos. If we want a world where we are automating safely and effectively and reliably based on data, then we need that discipline that comes in and thinks about the data's design, curation, stewardship, the whole thing. That doesn't exist at the moment. And I think that's going to be a very, very powerful area when we realize that data is the part here that really makes it all tick, the most important bit. The algorithms and the implementation don't need to be as sophisticated if the data is better. And yet we are not really building disciplines of excellence around how to get the right data. It doesn't exist. Data documentation, think about that. What do we know about it? It's a really hard research problem. Not enough effort is being put into it because we are still dazzled by the new kind of LLM, the new kind of neural network. So in order to make this all safer for everybody, we need to step up our interest here on both the data side and the decision-making side. The bit in between is almost the bit that can hold for a bit. When people ask me if I'm scared of AI, I say, the only way that question makes sense to me is if you're asking me whether I'm scared of human negligence. I can't possibly be scared of automation. Why? But human negligence in asking for the wrong thing automated in the wrong way, at scale, with disastrous consequences, that's terrifying. So when we think about AI ethics, a lot of those topics are just ethics of technology in general. And they're AI washed to make people interested. Let's talk about those important conversations as what they are, ethics of technology. When we talk about ethics of AI specifically, what we need to look at is that this is a thoughtlessness enabler. It is possible to be thoughtless, and it is possible to be thoughtless at scale. There is not that much research that is stopping us from being thoughtless. That's where the core trouble sits. It's very, very convenient when you can thoughtlessly automate some small thing for yourself. But when you realize that it is not just possible, but almost inevitable at the moment that large-scale systems come about thoughtlessly, that is where you should worry. And coming back to the two lines, what's the goal? Well, whose incentive set are we following? Are we documenting that? Are we able to audit it? Not at all. And what about which data do we use? It's too easy to say, hey, that database over there, no one opened it, no one checked, no one knows if it's any good. And then all of a sudden, we later have to find that there are issues with bias and underrepresented groups being hurt by these systems. That could be avoided if we had a diversity of people actually checking the correctness, or the appropriateness rather, of that data in the first place. So this is a place where you have the potential for massively amplified impact of individuals who are negligent. That's the big issue, and the one that if we're going to throw ourselves into a new area of research around this, that's where we should throw ourselves, in my opinion. At the end of the day, thinking is our responsibility, not just as users, but as citizens who understand that what's happening behind these systems is two lines of human thought, scaled up massively. This is an interdisciplinary area. It's an area where we have traditionally not been very good at collaborating with people, for example, philosophers, for example, designers, who seem like they are not core members of our field. Algorithms, PhD, or you don't get a say. This is how we're going to run into trouble. AI is more than that. And unfortunately, what AI is today is large amplified impact being kicked off at scale. Who is thinking about the responsible decision-making piece? That is the first bit. That is the thinking that is scaled up in any system. And it is our responsibility to think carefully about that and to make sure that we thoroughly test and safety net any systems that we build. Thank you very much.